Okay, let's unpack this then. Today we're doing a deep dive into, well, the future of how we connect wirelessly. Wi-Fi 7.
Hmm.
We've pulled together insights from some big names: Intel, Huawei, Qualcomm, MediaTek, Zexal, and Ritsu. New H3C. Quite the
Yeah,
list.
heavy hitters.
Exactly. And our mission really is to give you the shortcut to understand how this pretty game-changing tech is going to reshape your digital world. Think immersive gaming, smart homes, even those huge enterprise networks.
And it's fascinating, isn't it, just how vital Wi-Fi has become? I mean, it's everywhere.
Totally.
Our sources show back in 2022, something like 51%, over half,
Right.
of all IP traffic was already flowing over Wi-Fi.
Wow.
And the economic value, they're projecting it to hit almost $5 trillion by 2025.
5 trillion, that's huge.
It is. And that massive demand, it's growing all the time. That's exactly why this next step, this leap, isn't just, nice to have. It's really essential.
Okay, so that sets the stage. Now, Wi-Fi 6 and 6E, they were pretty great steps forward, right? Got us speeds up to what, 9.6 gigs?
Yep, 9.6 Gbps, and crucially, opened up that 6 gigahertz band. Less crowded.
Right, the less congested lanes. But, well, our digital lives just keep demanding more, don't they? We're talking 8K streaming like it's nothing.
Hmm.
Really high-fidelity AR and VR, cloud gaming where lag just kills it, complex industrial stuff.
Yeah, all that needs not just more bandwidth, but that ultra-low latency. Super responsive.
Exactly. So how is Wi-Fi 7, the tech spec, is IEEE, 802.11bb, right?
It's the one.
How is it actually built to tackle these, well, pretty huge challenges?
Well, fundamentally, it's engineered for what the experts are calling extremely high throughput, deterministic low latency, and increased network capacity.
Okay, break that down. Deterministic low latency.
Meaning it's not just low latency sometimes, it's reliably, predictably low, crucial for real-time stuff. But let's start with speed, because that's the headline grabber.
Right.
Wi-Fi 7 has a theoretical maximum speed, get ready for this, up to 46.1 gigabits per second.
Whoa, okay. 46.1 compared to 9.6. That's almost.
Nearly 5 times faster than Wi-Fi 6 or 6E. It's a
Yeah.
massive jump.
Okay, how? What's the magic behind that kind of speed boost?
It's a combination of things, really clever engineering. First, they doubled the maximum channel bandwidth, up to 320 megahertz now.
So like wider lanes on the highway.
Exactly, wider data highways. Second, there's a new modulation technique called 4.96 QAM.
4,000. Okay, sounds technical.
It just means it can pack more data into each signal, about 12 bits per symbol, which is a 20% jump over the old 424 QAM and Wi-Fi 6. Think like more efficient data packets.
Gotcha. More data per trip down the highway.
Precisely. And third, it doubles number of spatial streams. It supports 16 by 16 MIMO. More parallel conversations happening at once.
So wider lanes, more data in each car, and way more lanes overall. That paints a picture.
Yeah, that's a good way to think about it.
Okay, that covers the raw speed, which is
Yeah.
amazing. But back to that latency thing for AR, VR, industrial controls, where even a tiny delay matters.
Right, speed isn't everything there. You need that responsiveness. And this is where maybe the most groundbreaking feature comes in. Multi-link operation, MLO.
MLO. Okay, what does that do for you?
So your Wi-Fi 7 device, like your phone or laptop, it can actually use multiple frequency bands, 2.4, 5, and 6 gigahertz, all at the same time, simultaneously.
Ah, so it's not just picking the best one. It can use them together.
Exactly. Or switch between them seamlessly if one gets congested. It's like having multiple dedicated connections open all the time.
Okay, that sounds like it would make a huge difference.
It does. The potential is for like an 85% reduction in average latency, plus big throughput boosts, especially when lots of devices are competing.
85% reduction. Wow.
And there's another bit, multiple resource units, or MRU. It's about smarter scheduling of the channel resources, specifically cutting service latency by another 25%.
So does this mean like no more lag spikes when the microwave turns on or when everyone in the house starts streaming at once?
That's definitely the goal. Much smoother, more stable connections even when things get busy. And it makes better use of that 6 gigahertz band, too.
Right, more space, less interference up there.
Yeah, exactly. Which leads to what some folks are calling truly brilliant Wi-Fi. It translates into much better support for tons of users in really dense places, airports, arenas, campuses, you name it.
So putting all together for you, the listener, this translates into, well, a truly seamless, basically lag-free experience, right? For everything from crazy demanding VR down to critical stuff like industrial systems or even remote surgery, potentially.
Yeah, that's the promise.
It feels like Wi-Fi is evolving incredibly fast just to keep pace with how connected we're becoming, making things possible wirelessly that we used to absolutely need a cable for.
It really is.
Yeah.
Which, leads to kind of a big question, doesn't it?
Oh.
As Wi-Fi 7 delivers this massive leap, getting so close to wired speeds and reliability, enabling things we maybe didn't even think were possible wirelessly, are we getting to a point where that line, that distinction between wired and wireless performance just disappears?
Where it just doesn't matter anymore if you plugged in or not.
Yeah. And if that happens, what completely new ways of interacting, what new innovations will that unlock for you? What becomes possible when truly high-performance connectivity is just everywhere, untethered?